Welcome to this new video lecture of computer vision. In this video lecture, we will cover convolutions and blurring. A convolution is a mathematical operation performed on two functions to produce a third function which is typically a modified version of the original function. Output image is equal to input image convolved by our function of some kernel size. In computer vision, we use kernels to specify the size over which we run our manipulating function over our image. Blurring. Blurring is an operation where we average the pixels with the region kernel. We have a kernel or a filter whose number of rows are 5s and number of columns are also 5s and divided by 25. The above kernel or filter is a size of 5 cross 5. We multiply by 1 by 25 to normalize, that is sum to 1. Otherwise we had been increasing intensity. See these images. The left image is our original image and the right image our blurred image after convolution. The nice or unnecessary informations in the original image are disappeared in blurred image. Now we implement above concept of convolution and blurring in OpenCV. First we import our required libraries or packages, import CV2, NumPy and matplotlib. Run the cell. Okay, now we read our image which we want to blur. In this case our image name is elephant.jpg, which is stored on our Google Drive, and run the cell. Okay, we have read the image. Now create a kernel or filter of size 3 cross 3. Take a variable kernel underscore 3 cross 3 np. Use np.ones. Ones function. One function is used to create a matrix of 3 cross 3 whose all entries are 1 and its data type is float 32 and also divided by 9. Because a matrix whose order is 3 cross 3, the total element of this matrix is 9. Therefore we divide it 9. Now we convolve or apply above 3 cross 3 filter on original image for blurring or smoothing. For applying filter in OpenCV, a function which is called filter2d is used. Now we call function cv2.filter2d and pass the parameter as a parameter. First parameter is our original image and the second parameter our input. We give -1 and pass the above kernel whose size is 3 cross 3. Run the cell. Okay, go to next cell. In the next cell, create another kernel or filter of size 5 cross 5. The same code, only in this case the matrix is 5 cross 5 and divided by 25, because a matrix whose order is 5 cross 5 has total number of elements 25. And also convolve or apply our filter on the original image. Go to the next cell. Create another kernel or filter of size 7 cross 7. And this line of code, create a filter whose size is 7 cross 7, and this line of code apply above filter on our original image. Actually we are testing different filters of different size on our original image. Next, in this cell we show our results of convolution of above filters on our original image. First we plot a figure. This block of code show our original image and this block of code show blurred image after convolving 5 cross 5 kernel or filter. Sorry, 3 cross 3. Okay. Next, this block of code show blurred image after convolving 5 cross 5 filter or kernel. Okay. Okay, this is our original image and this image is the result of convolving after 3 cross 3 kernel, and similarly the result after 5 cross 5 kernel and the result of 7 cross 7 kernel. you can clearly see that if you increase the size of kernel, then the then the blurring of image is also increased. Thank you very much. See you in the next lecture.